Hi, my name is Matthew Gandasiawan, and today we're going to do ARP poisoning. What is ARP? Address Resolution Protocol is a part of the data link layer. It is responsible for discovering link layer addresses within a subnetwork. So it is considered an interface between layers 2 and 3, since it is centered around the Internet Protocol, Network Layer 3, and MAC Medium Access Control, Data Link Layer 2. It contacts and caches devices on a local area network. Can either be set up automatically or also be done manually. Caches will be removed after a periodic amount of time, depending on usage, and cache data is also stored on an ARP table belonging to a node. And then we can see here that there are various, we have this subnetwork, which has various devices connected to it. And we have the IP address and the MAC addresses. All these devices have each of these. So how does ARP work? Given an IP address, the machine will package a broadcast, encapsulating the IP address in its headers to resolve the corresponding MAC address. Packet is broadcasted to all devices on the connected LAN, and once a device receives a packet, it either drops or responds to the packet. It will drop the packet if the IP address doesn't match the node, otherwise it will respond back to the sender with its MAC address. Once the sending machine receives a response from the device, it saves the MAC address in an ARP table for future references. And again, it does remove it after a periodic amount of time. So what's inside an ARP packets? It's important to note that we want to focus on the OP operation and the hardware addresses and protocol addresses. So the operation represents whether the packet is a send or request, and the sender hardware address and protocol address, also the target hardware address and protocol addresses are the two devices communicating to each other. The sender address and the target address, very self-explanatory from the name. And then we have the ARP table in Windows. Windows holds its own ARP table and can be accessed through command prompt using ARP-A. And the columns in internet addresses, IP addresses, and physical addresses. So we have internet addresses, which are the IPs, and the MAC address, which is the physical address. And we also have type, which represents dynamic or static, we will discuss that later on. And I'm going to try pinging an iPhone from the Windows machine. And then we can see that by knowing the IP address, 192.168.168.119, we can get the physical address. You can see the iPhone settings on the right, the Wi-Fi settings, and on the left, the command prompt from Windows. So let's consider an ARP analogy. So let's say a post office wants to update a residence's street address. So we also have a USPS truck, which is essentially executing ARP. And then we have a parcel for Alice. We want to find Alice's MAC address or street address. And this is a vulnerable method because when we discuss ARP poisoning, we'll see why it's susceptible to exploits. So residents that aren't named Alice will discard the parcel. And when Alice receives her parcel, she will write back with her name and address, confirming that it is her. And then the post office and Alice will update their address books to the newfound names and street addresses from the headers we talked about earlier. So we have a couple of images here. Each of these sprites have their meaning in the animation next. So if you want to look over this. And then so we have the animation here. So we have the USPS truck visiting every house. It'll first visit Bob and it'll send a package to him, broadcast the package to him. But it's meant for Alice, so Bob will just discard this parcel and then goes to Alice, and the package is meant for Alice, so she'll actually keep this parcel and then she'll open up a request in the next slide, and then the USPS truck will visit other devices on the local area network. So responding to an ARP request, we have Alice who's opened her mailbox, and Alice wants to send this back to wherever the sender was. and the USPS truck will also make more stops, and we'll stop at Bob, and Bob has nothing to send, so we'll skip over to the post office and then retrieve the parcel from there, updating their address books. So let's take a more realistic example. We have two devices on a network, host A and host B. ARP request all all the devices, and receives a response from host B. So here are the potential dangers behind ARP poisoning. Packets are publicly broadcasted to each device with no security. It can be easily exploited. Devices can spoof their IP addresses, disguising themselves as other addresses or devices. Um, and then there is also the method is also known as a middleman, man-in-the-middle attack. And devices can spoof their IP addresses as a router, and then they can route to the victim and then also disguise as a victim to the router. So it's kind of a two-way attack of relaying all the information to the middle device. So let's take a look at this new analogy. We say that Bob is a pesky neighbor spying on Alice's letters meant for her friend in the next neighborhood, Charlie. As the USPS truck passes through Alice's and stops at Bob's, and Bob is going to pretend that he is Charlie. USPS driver doesn't much care. He's being only paid minimum wage and gives Bob the letter anyways. And Bob is finished reading the letter, modifies the contents if he likes, then hands it back to the USPS driver and says it's from Alice, destined to Charlie. This entire process happens without the knowledge of either Alice or Charlie. And then we can see the animation behind this attack here. You can see that it makes a stop at Alice, picks up the parcel, and then goes over to Bob, and who is disguised as Charlie, drops off the parcel, and Bob is going to take a look at this parcel and then hand it back up, disguising himself as Alice. And the USPS truck will drive off to Charlie, or through the post office, then to Charlie, and drops off the package, and Charlie doesn't even know a thing. So here's a more realistic example. We can see on the left that the router commutes directly to the system, and in another example on the right, the router is communicating with the attacking device, who is disguised as the system, and the router and then the system is talking to the attacker, thinking it's the router. So it's kind of the attacker is being two ways, acting two ways here. So what's the harm? Well, the examples were in small local area networks. The potential damage in even larger subnetworks is catastrophic. We can see in cafes where public internet access poses large security risks and someone's able to just spoof their IP address as anyone or yours. And any packet that you send through the subnetwork can be intercepted by the attacking device and can also be viewed if it was in plain text. So we need to see our discussion of dynamic versus static. We can see that dynamic addresses and also static addresses in the type column, it's saying that dynamic addresses are generated automatically from ARP, and static addresses were set by a user or administrator. And then we can see this method in ARP in preventing ARP poisoning, and such as the UCI mobile Wi-Fi mobile network access. Whenever you access the site with the new, or whenever you access the network with a new device, it will ask you to type in the MAC address manually, and uh, we'll have to use this MAC address to resolve instead of using the entire ARP process. So this prevents spoofing techniques and hindering its ability to resolve IP addresses and kind of act as the man in the middle. But static ARP entries may be tedious and less scalable. So here are the sources, and thank you so much for watching.